Okay, we have stopped the sign up. If you haven't signed up, you can talk to the TA later. So we have talked about how we are going to divide the user stories, and then we have 30 story points, and then we kind of divide into 5 story points for each 2 weeks iterations, and then that gives us 6 iterations. So I think for your projects, you also need to do this kind of estimations to help you to kind of plan ahead. The 2 weeks iterations actually, I think we may have more weeks for one iterations, because we actually have 3 kind of stage. First is the project proposal stage, which is due this week, and then after that will be the the progress report stage. Progress reports, you are kind of expected that you will implement one issues at least, and then after that there will be another issues that you will implement. So you kind of plan ahead. We make the planning much easier with a few stage, but between that you can have also another iterations for your purpose, if you want to kind of meet with your teammate more often. So in the planning games that you have tried, basically usually the customer write user stories. Like I was the one who write the user stories, and then the programmers estimate the time to do each user stories. If story is too big, then you split it. For example, the handle special characters, I only put it as one user stories. But then if you feel that it's too big later on, you can split it. And then usually the customer will choose the stories to match the project velocities. In your case, maybe you can choose it in a group, or you can let the leader to choose which is the one that to be implemented. And then basically the velocities is basically what is the amount of work that you have done in the previous iterations. That's actually help to summarize as well, like after these iterations, what is the things that you have done. That give you an estimation whether you have done enough or not. And then usually the things about planning is that I think this is also very makes this kind of things very prone to any changes, because we know that a lot of times plan will change, even for the GitHub issues, it may get fixed, some of them, and then some of them may get feel that actually it needs less time to change. So what is the benefits of this planning is that we only need to worry about one iteration at one time. Even though you have the plan for the kind of entire semester in the project proposal, but then you can change the issues, because the whole idea is that you worried only about one iteration. So it means that after you choose these projects, you mostly only worried about what happens in the next 2 or 3 weeks, whether you can implement what you are choosing for that particular iterations. Other iterations, you may worry about this later. And then, because if you plan ahead too much, we know that things may change. And then for simplicity, because we are adding one features at the time, we don't need to worry about future stories. And then you can make the programs as simple as possible, and then basically want to have the simplest things that could work, and then helps in your kind of planning. And then, but then the problem here is that we may need educated customers, in this comics, they say in extreme programming, we can give you all of the issues in the first iterations, and each features need to have what we call user stories. And then at the end, basically this person is saying, okay, here is the story, you give me all of my features or I will ruin your life. So I guess this is trying to show, of course, if you have such kind of customers, very much not really into negotiating, then it's not going to work. But in your team, I think that's at least you can do this planning, like playing this role of what is the features that you want, and then in the particular versions, and then instead of having all the features at one time. And then, so because we see that this XP actually needs customers quite a lot, so what we need for SP is that it will work best when there is educated customer on site that you can talk to, and then usually it's aimed for small team. The team that you have like 5 to 8 people actually is a good size for the team recommended in XP. And then also people who like to talk, I think that's important because you want to, even during the planning game, you know that actually you need to communicate. And then usually it works best when everyone is in one room. When if you want to have visually, it's also fine, but then everyone should be kind of in active chat in a group where you need to fix the time where everyone is actually available. And then another thing that I think this is the key features of XP is that it's actually aimed to focus on changing requirements, because we know that sometimes requirements keep changing. So compared to the waterfall model that you have seen in the first few lectures, that's only like kind of very strict steps that you need to first design and then later on implement. This is very good with changing requirements, because what you are doing is just planning for one iterations, and then later on you can change. And then what actually happens with XP is that they also advocate unit testing and refactoring, because code is very simple. Like adding one new feature tends to make it less simple when you add more code to the systems. So in this case, if you want it to be still simple, sometimes you may do refactoring. But for fixing a GitHub issues, you may want to be aware that refactoring is not really much a good choice, because it will have, it means changing a lot of files in the systems. Then you may have a lot of conflict, and then they also don't really recommend you refactoring their code, like adding spaces or things like that, make the pull request look very kind of messy or very big. But then in general, if you want to just handle that particular code that you have written, you think that the code that you've written is too long, then you can do the refactoring for that particular part. So the whole idea is to have introduce minimum code to fix the problems that you want to fix. And to do refactoring, you need to have a lot of test cases. That's actually one of the reasons why we ask you to run the test cases in your selected projects, because this test cases is useful later on. You before you make any change, you need to make sure that you know which test cases is passing, which test cases is failing, and then after you make some changes, you want to run these test cases in your project again, and then to make sure that you actually do not break any kind of test cases. And then, so that's basically the reason why for a working software, usually they have automated test cases, and then the whole goal is to have all the tests pass all the time. So if you are implementing a features, you want to be sure that even though you are implementing only partial codes, but each code should not actually break like something, break the test cases. So you need to be complete in this sense. And then when you work on a task, usually here I think there's quite good steps. Like usually you get the latest version of the code that's in your selected projects. You want to make sure you get all the latest versions. Sometimes they may change the versions. So you need to make sure that you pull the latest code every single time and then run the test, make sure that all the tests passes. And then you want to write the test first, and then you see that it's failing because you don't have the feature yet. So it should be failing. And then you write the code to make this test pass. Now all the tests passing, and then you refactor and then check in your code. This is the whole idea called test-driven development that will cover the step more in details in the next few slides. But the key practice is basically writing tests first and then writing code. You will see a video in the lab today, and then it will also show you the workflow of this writing tests and writing code. And then the whole idea is this is called test-first programming or test-driven development. Is basically testing kind of help you designing, and then you can actually stick to it to a certain degree for, depending on what kind of test you are writing. So there are, since we are starting to talk about testings, there are some consequence of bugs that want to talk about why we want to test. Like the whole idea is to improve qualities, to find bugs, and then we want to measure qualities, prove that whether there's no bugs. This is not really possible just because you write tests. Doesn't mean that your software doesn't have bugs. But usually tests could help you to check whether the software is kind of ready to be released for a certain test case that is important. If it's passing, then we kind of have a confidence for this. And then we want to determine what to work on next as well. If we see that there are some problems, we want to fix it, and then we want to see whether we make mistakes. And it's also good for learning the software. In the video that we will show in the lab section today, I think this is very good. And then I think in all the class that we are taking, like I think programming class, usually test cases is the way that they use to break your MPs, your assignments, to see how many test cases that your assignment pass. There are some costly bugs that usually I will cover this in the software testing class. So most, I think, very old now, but then still used as very recent example because they're actually very costly because, like, for example, the NASA Mars space missions, they actually have several bugs that cause the rocket to crash. And then there are BMW airbag problems that is to cause, there are some software issues that cause recall of a lot of cars. And then there is another crash in the, I think that's also a rocket crash. So maybe you have a favorite examples of your bugs. In software testing class, I usually show my favorite example, but recently don't really have so much example, but this video usually show just because it has really kind of impact, because you can see that the rocket is launching and then it crashed, and then the crash here is actually caused by the uncaught exceptions of numerical overflow, because when you have some floating point divisions and so on, then you are not doing the estimation correctly. It could cause a overflow. So that happens with a lot of this kind of rocket kind of, because it needs a lot of calculations to calculate the transactions of the rocket. So then if you have some problems, then it could cause a crash that because of an exceptions, you literally see the crash in the rocket. There are another one that I think more recent. This is, I think, also recent research because there are some crash in the Uber autonomous vehicle. So there are a lot of, I think, currently autonomous vehicle, or like even with autonomous kind of, I think we are trying to have autonomous bus in the campus, but then all of this may be subjected to a software errors, and that may cause a crash because they actually rely on software to calculate kind of which way to go and different things like that. In terms of economical impact, it could, I think this data is not so much valid. Now I think the cost will be much higher. So you can see that if you don't have enough testings, you may actually have a lot of cost you a few billions of inadequate testings, and then also there could be some kind of reductions in terms of if you can improve on the infrastructures. And then also there are some things in the, I think this is the stock markets that causes also 400 million kind of errors because of the computer bugs. So all of this shows that you will need testings. So testings in very broad sense is just basically you run and test, run the programs with an input and then you get an output. And then when you are checking this with these inputs, it could be a data, like for an image processing app, it can be an image itself. So these test cases may not be simple test cases. And then when you are checking the test cases, we have what is called a test oracle. And then usually the test either passing and or failing. So this colors is to show is usually we see the same color. So green is always good because you see all the tests passing, and then red is always bad because you see that there are some failures. What tests can be doing except for showing you certain kind of errors? It can actually help you to document a fix a fault. So in the unit tests or the test suites you see in your projects that you select, you can see that people actually write tests for a particular bug, and then some tests will have the name like bug number something something, and then you can see that they're actually trying to document this fault because this test was added when the bug was being reported, and then we want to add this to the systems. And then the test could also help to document the code, how you want it to be implemented. And then there are some terminologies that there are always confusions, like mistakes, a fault, or defects, or bug, failures, errors. I think all of you may think that all of this is the same, but then we will cover later that there is some difference. And then there is an oracle that basically sounds very fancy, but then it's actually talking about quite simple thing. So for the terminologies, usually when we say mistake is not really formal thing. So programmer make a mistake. So mistake here is not really so much terminology. But what is formal terminology here is fault. Fault here could be, you can just say bug, of course, but fault here means something appearing in the programs, and then it means like particular lines of code that you find that is buggy. And then this fault actually remain untested, undetected during testings, because we don't have a test to show that this fault exists. So that's why this fault is being undetected. And then the program failures basically occurs during execution. So you see failures here is like when you are running the test and then we get the failures. The failure actually happens because we observe that programs is not behaving expectedly. And then the errors is basically the difference between what is being computed or what is being observed, or what is being measured, or the conditions and true specify or theoretically correct values or conditions. So basically, errors here talk about you have something that is correct, that is true, or the expected values, there are something that is incorrect values. And then, so there is a difference between the terminology here. We see that there are several terminologies: mistakes, fault, failures, and errors. So fault is being detected when we are running the test inputs, when we have an input, and then failures is discovered during executions, and the errors is when we observe a difference between the expected behavior and then also the correct values. In another terminologies, like if you go to see a doctor, you will tell them, like, for example, when we go to see a doctor, we as a patient usually tell doctor that we have a list of symptoms. Like, let's say you trying to see whether you have a flu or something like that. You can tell doctor that you are coughing, and then we have like runny nose. All of these are symptoms. So that is like a failures in the software testing terminologies. And then what doctor trying to do is they're trying to diagnose what is the root cause for the ailment. There is the root cause, basically what is the things that causing you to have runny nose. Maybe you have some infections or something like that. That is like the fault. Or you can pinpoint which part, maybe you have infection exactly on your throat. So that is like the fault. And then the doctor may also look for other kind of anomalous internal conditions, like whether you have something like high blood pressures, whether you have irregular heartbeat, some bacteria. So this kind of not so normal conditions is actually the same as an errors. So in this case, we're trying to show you that difference between symptoms is the one that you can observe, the failures that you give to doctor, and then the fault is basically the root cause, and then the errors is basically the internal conditions. So want to have some discussions. What is in this example was the fault failures, and then also fault failures, and then also the errors. Okay. I guess people kind of get the answer. Don't really know whether you look at the slides before. Some people actually did not answer fault failures. They only answer error. So I guess maybe you are confused mostly with what is a fault and then failures, and then I think most of you answer about errors. So I think, like, I saw that most of you say about the fault being being I should be starting with 0. And then one person say that is the for is on for loop, and then one person say that there is no judge on the null array. Actually, in this case, like in this examples, if you let's look at what happens if you get a null array. So if you have a null array here, in the first line, you will not have any problems. But then when you reach the second line, actually, like there is a Java comments here saying that if array is now null pointers, this exactly what it will do, because it's called array.length, and then if array is null, then it will exactly throw a null pointer. So you actually don't need extra check for that. I mean, of course, like the null pointers, you can have a check, and then handle it some way. But if you don't want to handle this, it will do exactly what the comments is saying, that you just throw null pointers, and then you kind of can expect the user not to pass it null array at all. So that's also possible. But I think most of you get the correct answers, that when you want to kind of look at array, usually you need to start iterating through the array by starting the iteration at 0. I think for people who just get started with programming, that may actually make the mistakes of starting from 1. And then that may cause problems. But so basically here the fault, as I say before, fault usually is the root cause. So here the root cause is indeed that it should start at 0, not starting at 1. And then let's look at what did most people say about the failure. The failure, someone say the failure is like in the test, I should be start with 1, and then someone say the count should be 0 at return, and then there are, I think for failures there are more different kind of answers. They didn't actually talk about actually to show failures here. We actually need a test. I think some of you, only 1 or 2 students say that we need a test. So here, if we get a test, also depends on what kind of test that we get. So if we have a test that is like 270, and then this method is doing what it say, is counting the number of 0, and then we want to see whether we see that if we give it 270, the fact that we are starting at 1 doesn't really matter, because the 0 is not in the first position, so we still count it correctly. So the expected values and actual values is the same. So what happens is that, as I mentioned before, error here means something that is internal conditions. So here we can see an arrow. Basically, arrow is captured by the variable. So variable I here shows an error, because we see that I here should be 0, but then is become 1 in the first iteration. So this we actually observe an errors. Errors is something internal. So it's like the states of each of the variables that you see. But then failures only you can observe at the end when it's executed. But here we couldn't observe any failures, because we see that the expected values is the same as actual value. So we don't really have a bug here. But when we give it another cases, that is like have 0 in the first kind of element in the array, we see that there is a failures. of course, we still observe an errors because errors is like the variable I still have incorrect values. But this actually shows, this task case shows that the errors that we have in this line actually propagates to the return. So I think some of you are mentioning about count here. So failures here is actually only being observed when you get the final return values, which is we get the fact that the count is equal to 0 at the return statements instead of 1 that is being expected here. So this example, we see that given two test cases, it can show the error, like but not the failures. And then this test cases essentially will be more effective because actually this errors here is not so much observable if it doesn't propagate. So that's also when you design your test cases for your projects. Sometimes if you have the test that shows, like, unless you have something that prints every kind of things, like what is the value for I here, otherwise you can only observe the failures at the end and then your test will be failing. So ideally you want to see such kind of test cases. You want to keep this kind of test cases because it immediately show the failures, and then your goal will be to make these test cases being passing. So and then I mentioned briefly about test oracle here. So failures here actually depend on test oracle. What test oracle is doing in this previous example, we want to show what is the expected values and then what is the actual kind of values and then whether it matches. So but for these expected values is called a test oracle because usually that is like a ground truth in your systems. Like you want to know exactly for particular input what is the correct output. So that is not easily available for automated generated tests. So let's see, we have an example here. This very simple examples to calculate amount, and then we have a return value, and then we have balance. We want to double the balance and then add 10. But obviously we see that this is not doubling the balance. So what we have here is a test cases. Here is kind of like a unit test. So this test cases actually trying to get new account objects and then trying to set the balance being 1 to start with, and then we're trying to, when we call this calculate amount, it will because we want to double the amount and add 10, so it should be like equals to actually equals to 12. But then in the current state, we can see that it will return 13 instead. So that's basically the difference between this is that we want to have a test inputs here. We for very simple examples, usually you have a parameters and then the parameters usually is your test input. But in this case, because we are changing the field, so the field here is the test input. So the balance field is the test input. And then the test oracle will be this assertion here. We see that assertions assert true is set true equals to 12. So this tells us exactly what is the expected amount. So oftentimes you will need to check this by yourself. What is the expected values? And then you want to, when you run this test, you will see whether this method is producing the correct expected value. And then this shows structures that is called JUnit test. I think some of you have already experienced with JUnit test if you used to participate in the testing competitions. And then this is usually frameworks for writing and then running the test. JUnit is only one kind of lines. There are actually a lot of unit, like the XUnit. I think there is C++ unit. I think there is also Python unit. But so in terms of unit testings, I think there are framework available for many major programming language. But for other kind of tools that we will introduce in the class, I think there is not so much available in other language. So for JUnit test, it has the assertions that I talk about. This is the test oracle. And then you can also share some common test data among tests. And then you have test suites for organizing and running tests. And then you have test runners that shows you the red and green bars. And then this is actually quite commonly used in industry. I think like I think in Google that they need you to write JUnit test for every methods that you write. And then can be used as either standalone Java programs, or you can actually, if you use an IDE, you can actually run it with IDE. It's easier to run that way. And it can be used to test just entire objects, or you can actually test by checking how it interacts, different methods interact. Usually it's used in unit and integration testing, not really system testing. Some of you may be thinking what is the difference between unit testing and integration testing. Usually unit testing only tests a particular methods, and the integration testing, you want to test the interactions between several method call. Like what happens if you call method A and B, and then what is the expected output? That is kind of like integration testing, but then when you write tests at the code level, you kind of don't see the difference because it's almost the same. And then a test is basically just like a Java methods, and then test class could contain one or more test methods, and then you usually have a test class that have a test runner to run the test, and different test methods, and then you have for each test class you have a setup methods to set up the states before, and then you can update the states after each of the tests, before and after all tests been run. For writing JUnit tests, you will need to use some of the methods inside this assertion class. Assertions is, I say, is more like a test oracle. So you want to decide whether test is passing or failing. And then, and one thing about test cases that maybe some of you didn't notice is that test cases must be returning void. So don't return like integer in your test cases, because it's not exactly valid. Because test cases do not actually know what to return to. It's supposed to be used as a unit itself. And then you can use a lot of methods for checking different kind of assertions. The assert true methods I have shown in the previous slides. Usually you use assert equal because it can be used for many parts, like any kind of objects that have overloaded the assert equal. So it supports many types, like integers, boolean, and then even different objects or strings. You can use assert equals. And then assert null is more like, I think, more rarely used, only certain kind of things. And this fail method is usually used when you want to cache an exceptions. Within the exceptions, you use this fail. And then I think not so relevant. So an example unit has the one that more complete is that we have to import certain things like here. I think if you're using an IDE, all these things will be suggested to you what kind of import to add. And then I think the only difference is that you need to add the add test kind of annotations to each of the tests. And the tests need to be named kind of in a good way, because you want to know what kind of scenario you are testing for each part. It's also the test you may be committing to the repository that you are selecting. So that is also important, because they will also review your test, how good is written. And then assertion here, like for example, we can see that assert equal here when we are just calling assert equal, checking here is the kind of expected values, and then here is the actual value when you're calling these calculator methods. So essentially here, in this very simple test, we basically have the test inputs just directly as the input as this two parameter, 2 being parameter A and then 3 being parameter B. So this is very simple kind of test cases. Of course, for your projects, it will be more complicated. And then we have the expected results here. And then if you have no assertion, sometimes you can actually write a test cases without an assertion. And actually it helps even in if you take the testing competitions, it helps to increase your coverage because the coverage actually only consider whether you invoke the particular method. But the problem is if you are taking also the testing competitions, they also calculate the mutation score. So the mutation scores here already makes the assertions very important because assertions here actually helps you to check what is the expected values. And for normal test cases that you write to maintain the projects, of course you will need an assertions to check the particular values, because if you just call the methods without kind of knowing what is the assertions is not a proper JUnit test. And then there are also other things that helps you set up the states. There are initializations, like there is called prefix, and then there is reset values like a postfix, and then but you can actually use these objects without sharing the states as well. But sometimes you want to share the states because there are some common objects that you want to use across. And then you also should initialize this in an add before methods to say that you want this to run before each of the test methods. And then you can also use the allocations or reset in the after methods. So after methods is important, like if you let's say open the database in the add before and then you want to close the database in the add after, so that you kind of set up the states for the JUnit test. So in this example about an immutable stack class, we see more difficult example here. And then the effect here, we are returning a string, and then there is also other example here that is like returning a Boolean. So when you are testing this stack class, one thing is to import everything, but with IDE things are simpler. And then for the prefix, you need special annotation at before. Here in the prefix or the setup methods here, usually you can have an object. So here what it has is create a new stack for each task before running. And then you can have a postfix that is trying to set this stack to null, so that you kind of reset the stacks each time you're running the test case. And then after that, you just kind of like call this two string methods using assertions at the end. And then you can see that the test could be only like 3 lines of code. It can be like multiple lines of code because several things is more difficult to test. Like if you just want to test to string, is quite easy because you are testing the string representations. But if you want to check whether the state is okay, you will need to do some kind of manipulation, changing the stack certain way, and then call assertions again. But then one problem with this test is that I think this kind of test cases is better, because the one that you see in the right-hand side is okay if you are in a hurry. But then if you want to maintain a test cases, it's better to just separate, because we actually see 4 separate test cases here. In the previous slide, as I mentioned about each of the unit tests should have an assertions. But you can check, we have several assertions here. We have 1, 2, 3, 4 assertions in the whole test methods. And what happens with 4 assertions in this test methods is that if the first assertions fail, then it actually will not run the rest of the test cases. So that is kind of like a problem because we want to separate all the behavior into 4 different test cases. Each test ideally just have 1 assertions so that we can check each of different behavior in the particular parts. So if we separate into 4 parts, 4 different tests is actually better in terms of separations, or it also say about what is the scenarios that you are testing for each separate assertions. And then also the other part is if you don't have automations, if you're running a lot of tests and then some of the tests is really big, then you have the advantage of reducing cost of running many tests in the sense of, because you can have 1 test and then run just 1 test instead of a few tests, but then there is a problems sometimes as well. So you will see, I think, structure of different kind of test cases in the project that you select, big tests, big tests and small tests. But the benefit of small tests, of course, we can actually easily see the failures here is better. It helps us in debugging, so that's actually also a very important part. So we actually recommend that you split the one that you see in the slides before into 4 different test cases. And of course, this is not really good as well in these separations, because we see only test okay, wrap okay, A, B, C, D, E. You don't know what the A, B, C, D, E means, like which things they are testing. It's better to say each A, what is this testings? For example, we see that we only test whether the wrap okay is true. So this is like an empty stack, for example, and then we push 1 thing to it. So this is like empty kind of stack with 1 element. So they actually represent different scenarios. So it's better to put the scenario inside the test name. But in the other perspective, we just need to have all these different test cases, and then we can run it in an IDE, and then, or we can actually run it for command line executions. So when you want to run all the tests, you can put all of them in what is called a test suite class, and then so it needs to add certain annotations, and then you can run all the test cases. So when you are running the test cases, usually there are certain runner, but for your case, maybe you just use the JUnit test runner. If you want GUI-based test runner, you can use the JUnit Swing UI test runner, but I haven't used this. I think you may want to check what is the things that you need to specify in order to run this. But if you actually get a test failures, you can click on the test failures. It actually tells you the locations of the failures and exceptions that are being shown. That helps you in debugging. And there are some other topics that we will not go into details, like there are assertion patterns, how to decide whether your test is passing, whether we want to test about state versus interaction testing. There are parameterized tests that some of you may be thinking, because JUnit test, the normal JUnit test couldn't take in parameter as input. What if you want parameters so that you can call this test also? So there is something called parameterized unit test. And then there is JUnit theories that are trying to do something more advanced, but they are these 2 are still under, I think, experimental kind of sections. For exertion patterns, I will not go into too much details as well. So since we reached the end of the lectures, I will stop here. For those of you who haven't signed up, you can come and then we can show the sign up screen later.